Hello and welcome to another video. This is Cracking the Cryptic app Fog of War pack puzzle number 29. Tough pill to swallow. The rules are Fog of War. Correctly placed digits clear the fog around them. Classic. Every row, column and box must contain all numbers from 1 to 9 exactly once. Arrow. The numbers along the shaft of each arrow must sum to the number at the base. Pill arrow. Pill arrows sum to the 2-digit or 3-digit number in their base, read left to right or top to bottom. We'll get back to this. And lastly, partial kropki. A white dot between two cells indicates that the neighboring digits are consecutive. A black dot between two cells indicates that one of the digits is twice as big as the other digit. Not all possible dots are given. And lastly, we are given a custom rule saying that arrows do not cross or overlap each other or themselves. This rule will actually be quite relevant. So, this is a pretty difficult puzzle, and our main concern here is that I don't embarrass myself too much, not being able to do some basic arithmetic. And our second goal here is to remember to say at the very end of the video, when we hopefully solve this, this really was a tough pill to swallow. So, without further ado, let's begin by explaining the pill arrow rule a little bit. We see in the center, in the central square, that we are given the body of a pill arrow that extends in both sides of the fog. So this is all a pill arrow. Now let's just first explain what a pill arrow is. So it is either horizontal or vertical. And for example, if this number was a 4 and this was a 5, and this had a shaft that goes something like this, the numbers along this shaft would have to sum up to 45. And a pill arrow can also be vertical. So if the shaft went like this, the numbers along the shaft would have to sum up to, for example, if this was a 2 and 3, then that would be a 23, because it's read from top to bottom and from left to right. And it's either 2 or 3-digit long pills. So this is a case of it being 3 digits long. So without further ado, let's just quickly select every cell in the grid and fill it with every possible value that it could take. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. Now, we ask the question, how long is this arrow in the top right corner? Well, we see that it goes 1, 2, it's 3 squares long. If we give these the lowest values they could possibly have, the 1, 2, and 3, it will still sum up to at least 6, meaning that no number lower than 6 can show up here at the base. And in the other side, along the shaft, you cannot have numbers 9, 8, or a 7, because 6 plus 1 and 2 in the lowest terms would already give you exactly 9. Okay, so an important question you should ask yourself every time you're solving Fog of War Sudoku is, which cells are not in Fog of War? Because the puzzle makers are very intentional about these puzzles, right? And it's usually a pretty huge clue when you see that something is not in fog. In our case, we see that none of these cells are in Fog of War. And the fact that we don't see anything in these cells is a huge clue, because it means that this shaft of this pill arrow never crosses from one side to the other. So if it goes from the right, it never eventually goes up left of the line. And if it goes on the left side, it never ever goes over this central line. And that gives you an estimate of how high this sum can be. This sum can never exceed the sum of all cells in this Fog of War. So it can never exceed the sum of all of these cells. And this is 45, right? 45 plus 45, 90, 135. And even if we count all of these, that's 180. And you're not really allowed to count all of these because this cell is not a part of the sum. But even if we did count it, at most this can be 180. So it never crosses over to this side to be any higher. That means that this cell right here, which is the leftmost cell of the pill, it tells us the hundreds of the sum. And since it can't be 200, 300, 400, 500, 6 or 7, 800, or 900, that must mean that it is the number 1. Because this thing, as we said, it's at most 180. So, since this is number 1, and these two are consecutive, that's the 2, and this is the number 3. That reveals some new stuff to us. First, it reveals that the shaft of this pill arrow is actually on the right side, and it also reveals another arrow. This arrow is at least actually exactly 3 cells long on the bottom side, and at least 3 cells long on the top side. So that means that you cannot have values lower than 6 at the base, and you cannot have values over 6 anywhere along the shaft. So it cannot be a 9, 8, or a 7. Okay. Now we ask the question, can this value here in the center be the number 6? Well, you'll notice that the lowest possible values of these two cells on the shaft are 1 and 2, which sums up to a 3. And the lowest value here is a 4, which sums up to a 7. And that is already higher than the 6, meaning that this cannot possibly be a 6. What about a 7? Well, again, this would have to all be in lowest terms to be a 7, so it would have to be a 4, a 1, and 2. But without the number 1, this is a free 4, which sums up to a 7 plus 2, that's a 9, contradicting the fact that this must be the 7. So this also cannot be the 7. What about an 8? Well, if this was an 8, since this is a 2, that means that these two cells must be summing up to a 6. So it cannot contain the 6. And it cannot contain the 4, because if any of these two contain the number 4, the other number has to be a number 2 to get the 6. But the number 2 is over here. So these cannot be a 4, and it cannot be a 3, because 3 needs another 3 to make the 6. So that's a 1, 5. That means that number 1 is not up here. And therefore, in lowest terms now, this is 2 plus 3, which is a 5, plus 4, which is the lowest value here, that's already 9, contradicting the fact that an 8 must be here. Therefore, this cannot be an 8, and it is therefore the 9. This reveals two new facts. Namely, it reveals another pill, and it reveals that this arrow actually curls upwards. It goes to this square right here. And that is very important. So, no value here actually can, so let's start with this square. This cannot be a 9, 8, or a 7. Now we ask, can any of these 3 squares contain the number 6? Well, if it did, then this is a 4, and that's already a 10. So therefore, none of these can contain the 6. What about this? Can this be a 6? Well, if that's a 6, the lowest values here are 1 and 2, which is already a 9. And this would be unaccounted for, which is not allowed, so this cannot be a 6. Can any of these cells, these 3, contain the number 5? Well, no, because then this is just a 4, and 5 plus 4 is already a 9, so 2 cells would be unaccounted for. So none of these 3 can be a 5. What about a 4? Can any of them be a 4? Well, if this was a 4, for example, actually let's pick this one, because that's more arbitrary. If that's a 4, then this is also a 4 in the lowest possible terms, and that's an 8, and lowest value here is a 1, lowest value here is a 1, so the lowest value would be over 9, it would be 10, and that's not allowed. So number 4 cannot show up anywhere. It's even worse if it shows up here, right? Because if it shows up here, then this is a 4, and then this is a 1 and 2, not a 1 and 1, so that would be 11. So none of these can contain the number 4. Can this value up here be the number 3? Well, if that's a 3, and this is a 1 and 2, that's a 3 plus 3 is 6, plus 4 is a 10, so that is not allowed. So this cannot be the number 3. Okay. Now that really simplifies things a lot, and it makes it easier to answer this question. Can a number 1 show up anywhere outside of these 4 squares in this box number 4? For example, if it showed up here, then a number 1 would not be up here or down here. And then since that's a 2 free pair, you cannot have a free down here. But this is already 4 and 5 then. And that is by itself a 9 plus 2 is 11. So in lowest terms, this would not even work. Therefore, number 1 cannot show up outside those 4 squares. And next question we ask is, can a number 5 show up down here? So since this is a 9, 9 minus 2 is a 7. That means that these two numbers have to sum up to a 7. And a 5 cannot show up there because 5 needs a number 2 to make the 7. And 2 is already here, so 2 is taken, so this cannot be a 5. Can a number 2 show up anywhere here? Let's assume that it does. Let's assume that it's here, for example. It's arbitrary. So if that's the number 2, then you would not have number 2 anywhere here, right? And that gives you 1 free pair up here, meaning that again, you have very high numbers down here. That's a 4, 6, which is 10, which is greater than 9 already. So that does not work. So number 2 cannot show up outside those 4 squares. What about number 3? Can number 3 show up anywhere here? If that's a 3, then you run into the same issue. Then this is a 1 and 2. And since a 3 is up here, and that's again a 4, 6. So a number 3 cannot show up outside the shaft. And same is true with the number 4. So if this was a number 4, for example, number 4 cannot show up down here. And since these two have to sum up to a 7, 3 cannot show up here. So that's a 1, 6, meaning that a 1 isn't up here. So then that is a 2, 3, which is a 5, plus 4 is a 9, and this number would be unaccounted for, but it's also on the shaft. So that would have to be higher than 9. It would have to be at least 10. Therefore, number 4 cannot show up outside of the line. Okay, pretty good. Now, we asked the question, where does the shaft of this pill go? Can it go upwards? Well, no, because if it went upwards, it would either have to go this way or this way, and in both cases, it crosses the arrow. And the custom rule says that arrows do not cross or overlap each other or themselves. Therefore, the shaft of the arrow must be going downwards. And at most, it encompasses all of these squares. So let's assume that, in fact, it does actually encompass all of these squares. Well, what is the maximal value that it can have? Well, the maximal value that it could have is if these two are in the lowest possible terms, right? If this was a 1 and this was a 2, that is the lowest value, right? Well, in that case, this whole thing would have, this would sum up to 42. And now 42 plus 8, which is the maximal value here, is 50, plus 9 is 59. So in fact, that means that no matter how high we let this thing be, it cannot be over 59. So the highest digit it can have on the left side is a 5. But 5 is also the lowest digit that it can have on the left side. So therefore, the digit just simply is the number 5. Okay. Now these two are consecutive, meaning that this is the number 6. And now we see something new. Basically, we see that this thing is consecutive with both of these cells, so therefore this is the number 2, cannot be the number 1. Number 1 doesn't have two consecutive numbers. So these two digits are 1 and 3. This cannot be a 4, 5, 6, 7, 8, or a 9. So since that's a 1 free pair, you cannot have a 1 or a free show up anywhere else in that box. Okay. Now, let's keep going. What else can we do? Well, since the number 6 isn't a candidate here anymore, then the number 1 cannot show up here, because you need to make the 9, so that's a free 4, making the 7, meaning that the number 3 does not show up here. And now that reflects back on the lowest values these two could have, because this can no longer be a 1 and 2, because as you can see, this is a 1 or a 2. So the lowest values you could have here is a 1 and the 3. So let's keep assuming that this is in highest possible terms. So let's assume that this value right here is an 8. If that's an 8, then this thing would have to be a 7. So now, since this is a 4, this thing would be summing up to 41. 41 plus 7 is 48. And now, even if we let this have its maximal value, the value of 9, 48 plus 9 would be 57. That means that if we let this be the maximal value that it can be, and let this be the maximal value it can be, and this just resolves to a 7, this simply cannot sum up to a 58, contradicting the fact that the number 8 was assumed to be here. Therefore, that is not the number 8. So that is therefore the number 7. Now, this is an 8. So we don't know if this is a 1 free. We just assumed the maximal possible value this thing could have, and it still wasn't enough to reach 58. Okay, let's keep going. We also don't really know if it encompasses all of this, right? But it kind of has to. It kind of has to, because so let's keep the 1 free here for now. So again, if that's a 1 free, then this is a 41. 41 plus 8 is 49. 49 plus 9 is 58. 49 plus 8 would be 57. So this value cannot possibly be a 4, right? Because even if this was in highest possible values, that's a 41 plus 8 is 49. So if this was a 4, that would be 53. It would not be a 57. So this cannot be a 4, cannot be a 5, or a 6. Can it be a 7? So again, in the highest possible values, this is a 41, plus 8 is 49, plus 7 is a 56. So it cannot be a 7 either here, because no matter how high we let these numbers be, it couldn't reach a 57, and it must actually include all of these numbers, or it is simply going to fail to be as high as 57. So none of these numbers are allowed to be excluded. The shaft must actually pass through all of these cells. So this doesn't have to be a 1 and 3 though, and it doesn't have to sum up to a 4. Because if this was a 9, this can actually sum up to a 5. So this could be, for example, a 2 free. And in that case, this would sum up to a 40. And then with this, that would be a 49 plus 8. That would be a 57. So that also works. So essentially, what that means is that these two cells have to sum up to 4 or 5. So they cannot be a 6, 7, 8, or a 9. And it also cannot be a 5 itself. So they have to sum up to 4 or 5. Okay. Let's keep going. What else can we do? So it's probably about time to take a look at this thing up here, because you'll see that this cannot be a regular arrow, right? Because it's simply well, could this be a regular arrow? If it was a regular arrow, then this could not be. So you'll see that it's 1, 2, and 3 are taken, right? So if this was a 9, this would have to be the base of the arrow, and these two would be the shaft. This would be the 4 and 5. And then you would not have a 9, a 4, or a 5 anywhere. So does that work? I don't actually immediately see why it wouldn't. So 4 and 5. Huh. So we're not sure yet. Let's keep looking at other stuff. I see that this thing should be opening up because we placed the 2 over here. So 2 plus 3 is 5, meaning that this is the number 4. Okay, so now we see something useful as well. So we see that this thing is also an arrow. So let's go back. If this is a 9 and this is a 5, 4, so if this is an arrow, then this would also have to be a 4 and a 5, right? But that doesn't work because 4 and 5 are not allowed to be here. This cannot be, oops. This cannot be a 4 or 5 because if this was a regular arrow, lowest values here are 4 and 5, and this would have to be the 9. It cannot be the other way around. So this would have to be a 6 and 5 is 11. That does not work. So therefore, this must be a pill arrow somewhere here. Oops. All right. So there is a pill arrow somewhere here. Where is it though? Can it be a vertical pill arrow? Let's ask that question first. Well, no, because a vertical pill arrow would have to be summing up to at least 45, and these two would be disconnected, right? Because this would be on one side of the arrow and this would be on the other side of the arrow, and these 3 cells cannot possibly be summing up to 45. Same issue here. If this was the pill arrow, then these two would have to be summing up to at least 56, which is obviously not possible. So it cannot be a vertical pill arrow. What about the horizontal one? So this obviously doesn't work because this would have to sum up to at least 45. This also obviously does not work. Actually, why? Why does it not work? So if this was the pill, the shaft could be going like this, right? So let's check the values here. So this could be 9, 8, 7, and 6, which sums up to 30. And then these two could be 9 and 8. Right? So this could be a 9, and then this could be an 8. So that would be 30 plus 17, it would be a 47, and that can work. It can be a 4 and a 7. So it actually can go here. That's interesting. So how, again, so it goes down like this. Huh. Okay. So that would possibly work. Well, this cannot really be an 8-9 because we have an 8-9 down here, but it still can be 40 something, which is not good. Maybe we are missing something. Let's just go through the digits first and ensure that there's nothing too obvious. So for example, we have a lot of stuff we didn't do. So this is a free 4 pair, meaning that you cannot have a 3 or a 4 anywhere here. This is a 1-2 pair. You cannot have a 1 or a 2 here. This is a 1, 2, 3, 4. Okay, that solves it. So this is a 1, 2, 3, 4 pair, meaning that you cannot have a 1, a 2, a 3, or a 4 up here. So actually, now let's again assume that this is the pill. So the pill has to go down like this, right? This could be a 9, 8, 9, 8, 7, 6, summing up to 30. And this has to be a 9, 7, because it cannot be a 9, 8, summing up to 16. So at most it can be a 46, but this has to be a 50 something, because this is the number 5, contradicting the fact that that is the center of the pill. So that's not the pill. What about this? Can this be the pill? Let's assume that it is. So if that is the pill, then the pill goes down like this, but that is way too small. Yeah, it cannot go up and then down again because arrows do not cross or overlap over themselves. So that would be 9, 8, 7, and then this could have to be 9 and 7. So 9 plus 8 plus 9 plus 8 is 17, plus 7 is 24, plus 16 is 40, and obviously that cannot be. So at most that has to be exactly 40, but the minimum value here is 45, because this is a 4 and then this is a 5, so it cannot possibly reach 45, and therefore that doesn't work. So the only place left for the pill is in the top leftmost corner itself. Okay, so it has to be like that. And now let's trace the path, the maximal path that this thing could take. Okay, that is a pretty big path, but can it reach 70s and 90s? Well, let's check. 9, 8, 7, 6 is a 30, and even if we let this be a 9, 8, 7, that still doesn't reach 70 or 90. So that means that the leftmost digit over here has to be the number 4. Let me just get rid of the coloring, because we don't know if that's the path that it takes or not. So that's the number 4. Okay. Can this possibly be a 49? Let's assume so. Since these two are consecutive, then this would have to be an 8. And the highest value this could have would be a 7, 6, 5, right? And then this would actually be going down as we saw. It would be going up like this and then down like this. And then the maximal value of these cells, so it cannot have both an 8 and a 9, so it should have a 9, and then, well, not there, but a 9, and then a 7 and a 6. Okay, so let's sum these up. 5 plus 6 is 11, plus 7 is 18, plus 8 is 26, plus 6 is 32, plus 9 is 41, plus 7 is 48. So that would not be summing up to 49. Even if these cells were allowed to have the maximal possible values, they could not sum up to 49. Why? Because again, this is a 8, 5, 6, 7, and this cannot have both an 8 and a 9 because of this cell down here. So at most, these sum up to 48. Therefore, that is not the number 9. What about number 5? Can that be a 45? Well, if it is, then again, this thing, let's check its value. This could be a 9, and then this has to be 7, 6, 8. So 6, 7, 8, 9, summing up to 30. And then what is the lowest value you could have here? Well, 5, 6, and 7. Okay, so yeah, this can work like this. Basically, if a number 5 is up here, right? That is the number 5, then a number 5 is nowhere here, which gives you with a 6, 7, 8, 9, right? So this is a 6, 7, 8, 9, which sums up to 30. And the lowest values here are 5, 6, 7. 5, 6 is 11, giving you a 41, plus 7, that will give you a 48. So the lowest possible value you could have is with a 5, 6, 7 here, and 6, 7, 8, 9 here would be 48, contradicting the fact that this thing sums up to 45. Therefore, this is not the number 5. Okay. Is it a number 6 though? Well, if it was a number 6, again, this would now have to be 5, 7, 8, 9, which is 29, right? Let me check. 12. 12 plus 8 is 20, 29. So that is a 29 plus 5, 34, 40, 47. So the lowest value here would be a 47. And that is higher than the 46, which is allowed. And keep in mind that we can't really ever allow ourselves to not take this full path, right? If we imagine that it doesn't take this full path, if we imagine that, for example, it goes down like this, then you'll basically see that highest values here could be a 9, 8, and now this would have to be a 7, 9, and that is simply nowhere close to reaching, and this would have to be a 7, right? So 8, 9, 7, that is 24, right? 9 plus 8, so yeah, 24, plus 16, that is simply 40, and that is nowhere close to being 45, 46, or 48. So it has to consider the full path. And therefore, this also cannot be a 6, as we saw, because if it takes the full path, then it sums up to 47 at minimum. So therefore, this is the number 8. And since these are consecutive, then this is the number 7. Now, that's a 5-6 pair, meaning that you cannot have a 5 or a 6 anywhere here, meaning that this is the number 9. And so this is an 8, and now this is a 9. Okay, now a number 9 here actually means that these numbers sum up to a 5, if you remember with this whole thing down here. So this has to be summing up to a 5 for this thing to sum up to 57. Okay, what else can we do? Well, actually, this is 9 plus 7 is 16, plus 11 is 27. So that means that this thing has to sum up to 21. And if this thing was a number 5, if it had a number 5 anywhere, especially here, then that would mean that it would have to have, since it must sum up to 21 here, it would need to sum up to 17 down here. Not 17, it would have to sum up to 16 down here. Can it sum up to 16 though? No, because 8 and 7 are the highest digits, which sum up to just 15. So a number 5 cannot show up anywhere here, or else this would not be summing up to 21. So this is a 6, and now this is 15 and 6, which gives you 21. So since that's a 7-8 pair, you cannot have a 7 or an 8 anywhere in the same box or column, giving you the number 5 down here. Okay. What else? Now this is the number 9. These two are consecutive, so it cannot be a number 5 in there. And that leaves you with this thing. So these numbers are consecutive, and these three sum up to a 9. Let's go through slowly. Can this be a 6? If that's a 6, then this can be a 1 and a 2, so that works. Can this be a 5? No, because then two consecutive numbers would have to add up to 4. So this cannot be a 5. Can this be a 4? Yes, because this can be 2 and 3. Can this be a 3? Then you would need to have two consecutive numbers adding up to 6. And that does not work. So this cannot be a 3. Can it be a 2? Yes, because then two consecutive numbers would be adding up to 7, and that is a 3 and 4. And can this be a 1? Obviously not, because you cannot have two consecutive numbers summing up to number 8. So that is a 2, 4, or a 6. Can this be a 6? Let's check again. If that's a 6, then this is a 1 and 2. That seems like it works. Let's check this cell. So, can this be a 6? Obviously not, because it would need a 6 and 5. 4 and 3 is 7. Plus 2, that would work. 3 and 2 is 5. Plus 4. And 1 and 2 plus 6. That all works. Dang it. Let's go through the digits maybe. Maybe that's going to reveal something to us. Oh wait, we actually do see something. Number 5 can no longer be up here, meaning that the number 5 can only show up here in this row. So that is the number 5. And now we have a 1 3, 1 2 3 4, 1 2 3 4. That's a quadruple, meaning that these two cells cannot possibly contain a 1, a 2, a 3, or a 4, giving us the number 6 here, meaning that this is a 1 and 2. Therefore, 1 and 2 cannot be anywhere down here. That gives us number 3 here, number 2 is here because they're consecutive, so this is a 1, and this is the number 2. Then this must be the number 5, this is a 6. And let's see if maybe anything new reveals itself. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Okay. So we do see that these cells are consecutive actually. So that should help us out a little bit. For example, if this was a 5, then this would be a 3, 7, 8, and it could not have a number consecutive with the 5, and same is true here. So number 5 is not there, and therefore the number 5 has to be right here. Okay. So a number 4 has to be here somewhere, right? It's either here or here. Okay. And we have a number consecutive with the 4 either here or here. Let's check the 4. So number 4 is either here or here, meaning that it cannot show up here. One, 2, 3, 4, 5, 6, 7, 8, and 9. Well, this actually already kind of reveals some new stuff to us. Namely, the fact that the shaft of this pill does not actually encompass the entirety of this box. At most, it goes down, encompasses all of this and this, and that is 45 plus 45 is 90. And then what are the highest values? Let's check the highest values it could take in these selected squares. So 90 plus whatever is in here. So this could be, in order for these to be the highest values, right? Then this would have to be the number 3, and then this would have to be the number 1, right? So all numbers here would be 4, 5, 6, 7, 8, and 9. So 4, 5, 6, 7, 8, 9. Yeah, so the only numbers missing would be 1, 2, and this 3 over here, which sums up to 6. So everything on the orange line would be summing up to 39. 39 plus 5 is 44, plus 8 is 52. So 52 plus 90 is still just 100. So 52 plus 90 is 142. But as you can see, even if we let everything be in its highest possible terms, it never reaches 160 something or 180 something, meaning that the highest number here that you could possibly put is in fact the number 3. Okay. Now, that tells us that a number 3 must be somewhere here. Okay. 3, 5, 4. So, this is a bit difficult to explain, but if this is a 3, and the 3 must show up somewhere here, right? If this is a 3, then this is a 4, because they're consecutive. But now a 4 cannot be here, so then this would be a 7, 8. And that would mean that this cannot be a 5, because it would have to be a 7, an 8, or a 9. And same is true if this was a 3. So if this is a 3, then this is a 4, and then this is a 7, 8, and these two are consecutive, so this cannot be a 5. So because a number 3 must go in one of these two cells, neither of them can contain the number 5. And so a number 5 is somewhere down here, so it's not here, and it therefore must be somewhere up here. Okay, slowly making progress. So we have the number 5. Let's go through all the digits again. 1, 2. Well, we have something new here. These two cells are consecutive. I didn't see this immediately. So this cannot have a 1 or a 4. So then that is a 6, a 7, or an 8. Now, can this thing be an 8? So if this is an 8, then you don't have an 8 here. And this would be a 6, so you would not have a 6 here. And that would be a 7, 9 pair, which is not consecutive. So that contradicts the assumption that the 8 is over here. Can this cell be a 6? Or this cell down here? Can either of them be a 6? Well, if that's a 6, then this is an 8, meaning that the 8 is not here. So that's again a 7, 9 pair. So nowhere down there can we have a number 6. So neither of these can be the number 6. Okay. So 1, 2, 3, 4, 5, 6, 7, 8, and the 9. Okay, so we don't actually have much left. Let's just assume that this cell right here is a number 8. And let's see the highest value that all of these cells could possibly be summing up to. So again, this is 45 plus 45 is 90. So we'll just remember 90 and just select all of these squares. Right? So since this is an 8, you cannot have 8 anywhere else. And obviously, since that's an 8, let's assume that this is in highest possible terms. So then this would have to be the number 1. And that way, this orange thing is in highest possible values. So this would be 3 plus 4 plus 5 plus 6 plus 7 plus 9. Now we just have to add all of that up together. So 3 plus 4 is 7, plus 5 is 12, plus 6 is 18, plus 7 is 25, plus 9 is 34. So this sums up to 34. 34 plus 5 is 39, and the highest value here is the 8. Oh my god, I forgot. I forgot how much it sums up to. So, oh yeah, 39. So 39 plus 8, that is a 47. And now a 47 plus 90, that would still be just 137. It would be one number shy from being 138. So therefore, that means that even if everything on the line was in its highest possible terms, it would still not be high enough to reach 138. Therefore, this cannot possibly be the number 8. It must be the number 6. And now, since that's 6, this is a 7979. We don't have a 7 or a 9 here. That gives us 156 triple, and this is a 248, meaning that an 8 isn't up here. So therefore, this must be the 8. Now this is a 1414. Actually, it's not. My bad. But what do we have? Number 8 has to go in here in this box. And now that reveals some new stuff. Essentially, it reveals that this thing is not really a part of the shaft. So why? Because if it was, it would not be able to go over here without crossing over itself, right? So it cannot go diagonally over itself. So at least 2 squares aren't a part of the line down here. Now, before we reason about them, let's just keep going and keep adding stuff together. 1, 2. Okay, that's a 3. 4, 5, 6, 7, 8, 9. Yeah, I don't see anything more. I suppose we have to just start adding stuff up together again and see how we can obtain this 136. So let's just assume again that this is in highest terms. So this would be the number 1, meaning that this, let's just select first everything that is on the line. Presumably, this is the maximal amount the line could take. So it would encompass everything except for this square right here and this square right here, because we don't see it on the line. And since we're assuming it's taking its maximal possible value, that means that the number 1 has to be here. So this is again 1 and 2 and 6 are here. So therefore, that is 3 plus 4, which is a 7, plus 5, 12. 6 is taken, right? It's right here. So plus 7, it's a 19, plus 8 is 27, and plus 9, it is 36. So the green line here sums up to 36. And let's just remember that for now. Actually, 36 plus 5 is 41, right? And the maximal value here is, again, an 8. So let's just give it the maximal value, which is 49 for this line right here. So if that is a 49 and this is a 45, so that would sum up to 94 together. And now let's assume that these two cells are in the lowest possible values, right? Because we said that we are assuming the highest value for the green line. In that case, this thing would be summing up to 42. But in that case, we have a 94 plus 42, which would be summing up to exactly 136. So if the line went through all the selected cells, which were the only possible, all the possible candidates, right? So if it went through all the possible candidates and all the possible candidates had the maximal possible value, then and only then would the sum be 136. And since the sum must be 136, then everything really is as we considered, because in no other configuration could it possibly reach a value so high. Therefore, this really is the number 1. These two really are the 1 and 2 pair, so they cannot be 4, 6, 7, or 9. So you cannot have a 1 or a 2 anywhere else. And so this is a 6, this is a 5, this is a 1. This really must be the 8 to be the highest possible value. This is a 7, this is a 4, 8, 7, 9, and 3 and 4. 9, 8, 4, 2. And now this is a 7, 9. This is an 8. And this is a 3. This is a 1. Now that's a 2. This is a 1. And now if you remember, we said that these two cells must be summing up to 5, because basically this number right here is a 9, because they have to sum up to 57. So 57 has an 8 plus 9, which is 17, plus 8, which is 25. And now if this was in its highest possible terms, it would still be able to reach 57 if and only if this thing sums up to the number 5. So this cannot be containing the number 4 here, because then this would be a 2. All right, so that leaves us with this thing. Can this be a 4? No, because again, if this is a 4, then this is a 2. Again, that's a 6, so this has to be a 2 3. So this is a 4, this is a 3. This is a 1 and this is a 2. 6, 1, and 2. So number 1 must be here. That's a 7, 9. That's a 7, 4, 5, 3, 6, 9, 3, 7. And then that's a 7, 4. And the puzzle is finally complete. That really was a tough pill to swallow. Honestly, I hated this puzzle so much. I think, I don't know, like, it's a good puzzle, right? But it's just so there's no calculator, right? So you constantly have to sum numbers together and constantly have to think about the results and the sums. It's a cute, I don't know, it's a cool puzzle. It is very hard though. So thank you guys for watching, and see you in the next one.